Now onto the problem set for chapter 16 dealing with oxidation reduction. So let's look at these things and identify the substance being oxidized and reduced in each chemical reaction. So definition of oxidation is loss of electrons. You can also gain oxygen. You can also lose hydrogen for organic molecules. So literally, magnesium is gaining oxygen. You can see it's adding oxygen. It's also losing electrons. So magnesium goes from magnesium metal, magnesium plus 2 ions. So magnesium is being oxidized and the oxygen is being reduced. Now, same thing, the metal metallic iron is reacting with chlorine, and the iron loses electrons, becomes oxidized, while chlorine gains electrons, becomes reduced. And now you start with zinc. Zinc gives electrons to iron plus 2. The zinc loses the electrons, it becomes oxidized, and the iron plus 2 is being reduced. So looking at that. Identifying the oxidizing agent and the reducing agent. So it's kind of like completely confusing for the students. The oxidizing agent is the one that causes oxidation. And how does it cause oxidation? It does it by being reduced. So we've already identified that magnesium is being oxidized and oxygen is being reduced. So oxygen is the oxidizing agent because it's being reduced, and magnesium is the reducing agent because it's becoming oxidized. So same thing for each of these metals. So iron is being reduced. Iron is being oxidized. Iron is being oxidized, therefore it's a reducing agent, and chlorine is being reduced. Therefore, chlorine is the oxidizing agent, and B. And for C, zinc is being oxidized, iron is being reduced. Therefore, iron plus 2 is the oxidizing agent, and zinc metal is the reducing agent. So, going there. Assign oxidation states for each atom in the species. So for bromine, it's an element, and it's 0. So that's the rule there. So potassium plus 1, it's a monatomic ion, and the oxidation state is the ion's charge, so it's plus 1. So for lithium fluoride, the sum of the oxidation state for lithium and fluorine has to be 0 because lithium fluoride is a neutral unit. And lithium is an alkaline earth that tends to be plus 1, and so that forces fluorine then to be minus 1 by lithium being plus 1. So, okay. And now then for carbon dioxide. So the sum of carbon plus 2 times oxygen equals 0 for the sum of the rule state there. And oxygen tends to be minus 2. So plug in minus 2, so carbon's oxidation state plus 2 times minus 2 equals 0. That forces carbon then to be plus 4. So the oxidation states then for this carbon is plus 4, and each of the oxygen is minus 2, and the sum of them equals 0. So now for sulfate, it's similar. You sum up the oxidation states, but the sum of the oxidation state equals negative 2. Because it's an ion, and the ion equals its charge. If it's a neutral compound, it would be 0. But it's not a neutral compound, it's a charged compound, or a charged unit. So the sum of the oxidation is minus 2. So then it's sulfur's oxidation state times 4 times oxygen's oxidation state. And there's a 4 there because there's an SO4, the 4 units of oxygen in the ion. And we can plug in negative 2 because oxygen tends to be minus 2. And then sulfur's oxidation state minus 8 equals negative 2. That means sulfur then is plus 6. So sulfur is plus 6 and oxygen is minus 2 for each of those. And you can check the sum of them, and it does in fact equal negative 2, so you've done it properly. So for sodium peroxide, and I'm probably giving the name away, a peroxide, definition of peroxide means oxygen in the minus 1 state. So if you hear the words like hydrogen peroxide or benzyl peroxide, that means there's oxygen in the minus 1 state. But sodium peroxide here, you have 2 sodium's oxidation state plus 2 oxygen's oxidation state equals 0. Sodium is an alkali, and the hierarchical rules is +1 with that, and it takes precedence over the oxygen. And so the +2 times oxidation equals 0. That means oxygen equals -1. So oxygen tends to be -2, but here's the word tends to be. It doesn't mean it's always -2. It just tends to be -2. It can be a -1 in peroxide. Well, definition of peroxides is oxidation -1. You can even have fractional oxidation states. So a superoxide is when it's -1/2, for instance. So that's more advanced than this course. So you can go and check, but there it is. And remember, though, the rules are hierarchical when it comes to the oxidation states, which means rule 1 is more important than rule 2, and so on. So let's use oxidation states to identify oxidation reduction. Calcium metal plus 2 waters makes calcium hydroxide plus hydrogen. Let's write the oxidation states for each. So calcium is metal, it's 0. For water, it's +1 for hydrogen, -2 for oxygen and water. Calcium hydroxide +2 for calcium and calcium hydroxide, -2 for oxygen, +1 in the hydroxide, and hydrogen is 0 because it's an element. So calcium is going from 0 to +2. It's losing electrons. It's oxidized. Hydrogen is going from +1 to 0. It's gaining electrons. It's being reduced. So, and furthermore, calcium is the reducing agent and water is the oxidizing agent for this. So let's balance redox equations using the half reaction method. So we're going to go up increasing complexity with this. And this is something students do find really hard. So pay attention to this. So aluminum metal plus copper +2 makes aluminum +3 plus copper metal. Aluminum is going from 0 to +3. It's losing 3 electrons. Copper is going from +2 to copper 0. It's gaining 2 electrons. It's reduced. So we have to look at this. Aluminum is being oxidized. Copper is being reduced. And now we have to do the half reactions for this. This one's easier, though, because we don't have any hydrogens or oxygens. So aluminum going to aluminum +3 is generate 3 electrons, and 2 electrons are needed to form copper +2 into copper metal. So we now have 3 and 2, and we have to look at the lowest common factor. The lowest common factor between 3 and 2 is 6, because 2 and 3 are both prime numbers. So it makes sense. So we have then the 6. So we need 2 aluminums plus 3 copper ions makes 2 aluminum ions plus 3 coppers in this reaction. And let's make sure that we've had all the atoms. We have 2 aluminum atoms on each side, we have 3 coppers on each side, and we have 6 electrons being generated and consumed. So this is all done properly. So let's look at one a little more complicated. So now we're going to take iron +2 plus permanganate to make iron +3 and manganese +2 ion. So iron is being oxidized, going from +2 to +3. Permanganate is the magnesium is going from +7 to +2. So iron is generating an electron. Manganese is absorbing 5. So we have to look at this, and let's balance each half reaction though. So iron is easy, it's straight away. So now we got to balance out the permanganate. So permanganate going to manganese. So there's 4 oxygens on the left of that. Now we need to add 4 waters on the right to balance those 4 oxygens. Now we have 8 hydrogens on the right, so we need to add 8 hydrogens on the left. Okay, so now we've balanced each side then, and Also, look at the electron transfer. So iron plus 2 to iron plus 3 generates 1 electron, and the permanganate equation consumes 5 electrons. So the lowest common denominator between 5 and 1 is 5. So we have to multiply the top number by 5, the iron by 5, to generate those 5 electrons for the permanganate to be consumed. So now we have to add the equations together, and we get the equation there as written. So, and cancel out wherever it is, and now we're done. So let's check both sides. We have 5 irons both sides, 8 hydrogens, 1 manganese, 4 oxygens, and well, I would think of it as plus 17 charge. I usually think about the electrons being consumed. We have 5 electrons being generated and consumed. So, however you want to balance it that way. So, let's do an acidic solution now. We just did the last one, an acidic solution that was implied, but this is a hard one, so we can do another problem with this. So, iodide plus dichromate makes chromium plus 3 plus iodine. So this one's a little more confusing because of the iodide. And the iodine, you actually have to have the 2 iodides there. So, but iodide is being oxidized. Chromium going from plus 6 to plus 3 is being reduced. So let's look at the half reactions here. So balance the elements, and the iodide is going to be, this is where the students get messed up on this one, because you need to have 2 iodides to form iodine, and it generates 2 electrons. So let's balance the dichromate. So the dichromate, we need 7 oxygens on the left, we need 7 oxygens on the right. Now we have 14 oxygens on the right, so we need 14 hydrogens on the left. And now we've balanced that, and now we have to look at the charge. So iodine generates 2 electrons of that half reaction. The dichromate absorbs 6 electrons. And why is it 6? Because you see there's 2 chromiums there in the dichromate, and each one is going from plus 6 to plus 3. And there's 2 of them, so you need a total of 6 electrons. Lowest common denominator between 2 and 6 is 6. So we need to multiply the top equation by 3. And we got to add them together. And then we're left here. So 14 hydrogens, actually 6 iodides plus 14 hydrogens plus dichromate makes 3 iodines, 2 chromium plus 3, and 7 waters. So we have 6 iodines, 14 hydrogens, 2 chromium, 7 oxygens, and 6 electrons are transferred. So with this also, so keep in mind where the electrons are going, and see also that we have in the iodide ions and the chromium monatomic ions, make sure those are balanced with this, so it can be a little complicated that way. But I actually enjoy these. I know I'm weird. I think these are fun. I actually used to play a game on my cell phone that had oxidation states. Unfortunately, it's no longer supported with more advanced versions of software, so I can't play the game anymore. Okay, so let's do this now with basic solution. Basic solution is the same thing as an acidic solution, except then you neutralize with hydroxide instead. So you balance it first in acid, and then you neutralize with the hydroxide. So here we go. Cyanide plus permanganate makes CNO minus and magnesium 4 oxide. So the carbon is being oxidized, going from plus 2 to plus 4, so it's losing 2 electrons, and the manganese is gaining 3 electrons in this. So now we're going to go ahead and do what we've done before and balance them in acid. So with the cyanide, to get the CNO, we're going to have to add water to get the extra oxygen to their side, And for permanganate, we got to add two waters on the other side. Now, with the cyanide, we have to add 2 hydrogens on the right to counteract the water. And the permanganate, we have to add 4 hydrogens to counteract the 2 waters. And now we're going to neutralize with hydroxides on both sides. And those hydroxides are going to come together to form waters. And now we have to subtract away any waters. And now we have the half reactions in an alkaline solution, in the basic solution. Now we can see that the cyanide reaction generates 2 electrons, and the permanganate reaction consumes 3 electrons. What's the common denominator between 2 and 3? It's 6. Multiply the top equation by 3, the bottom one by 2, and now we add them together, and we have them as such. Now we can check, make sure we have each of the atoms, and we have 5 electrons generated. Oh, we actually have 6. We have 6 electrons generated, 6 electrons consumed. I don't know where this charge comes from. I just think in terms of the electrons. So let's go on and predict spontaneous reactions. So first of all, where is each of these spontaneous? A manganese is more reactive than iron. Therefore, A is not spontaneous. So A is not spontaneous. B, on the other hand, is spontaneous because lead is not. It's below. So the half reaction is below it. So for the iron and the lead, it actually is spontaneous. So it has to deal with its position in the activity series. So same with that. Does chromium dissolve in hydrochloric acid? Yes, because chromium is more active than hydrogen in the activity series. So most metals will dissolve in acid. The ones that aren't are the expensive ones like mercury, silver, gold, platinum. So and some of the acids, so nitric acid, for instance, can get some of them to dissolve even further. So mercury, silver, and copper will dissolve in nitric acid, for instance. But that's a little bit more of an advanced topic for this class. And we are done. Thank you very much for listening.